So when it comes to the semiconductor, we know their property lie between conductor and insulator. That's why they are half conductors. Semiconductor means half property look like a conductor and half like insulator. Correct. And these semiconductor have lot of application. That's why we are studying in our syllabus. And today, modern world, we can't imagine without semiconductor. All the electronic device you see in your surrounding have this semiconductor. All the electronic device means literally every electronic device include the semiconductor. I'll give you example. Uh, in this electronic devices you have TV, you have FM radio, mobile radio, mobile, then computer, then what else? This in olden time we used to have VCR, VCD, correct? Radar, like all the vehicle, especially this aeroplane kind of thing, correct? Missiles, guided missiles. Then in medical you have X-ray, you have ECG. In medical field you have EEG, electroangiograph. So it's like whatever you can think about a modern device will always have semiconductor. That's why, one of the reason why not China, Taiwan is very rich, even it is a small island country. Main reason is semiconductor. Taiwan is the only country that produces finest semiconductor in the world. And only, remember, only. China is uh, controlling everything is a kind of superpower, but still, when it comes to the semiconductor of Taiwan, they are top runner. Taiwan, when it comes to the semiconductor. And in this all electronic devices, interesting thing is you don't use these AC. You always require the DC supply. Very important because when we think about the electricity, we think about the AC, alternative current, because that's what available in our houses, right? But all these devices are using this DC supply. Very important first question. Correct. Second basic question, comparison. Like how you compare conductor, insulator, and semiconductor. So I will write here one, two, and three. Okay. So here we'll talk about the property, conductor, insulator. Why these two before? Because you have two extreme versions in conductor and insulator. And why semiconductor is written in the end? Because here property lie between conductor and insulator. You can compare. Example, if you talk about free electron, first property, do you have free electron in this case? Yes, a lot in case of conductor, a lot. Insulator, negligible, very few. And semiconductor, few. Few means between conductor and insulator. Correct. Second is conductivity. Can it pass current? So based on the conductivity, you can say they have very high conductivity. Insulator have very low conductivity, and this will intermediate. So whenever you compare, it lie between conductor and insulator. As simple as all the property of semiconductor, most of the property, not all, lie between this. Example, if you talk about the resistivity, Jordan, what will happen to the resistivity?
So in conductors, the resistivity will be low, insulators it will be high, and semiconductors medium.
Exactly, intermediate medium. Correct. Yeah. Fourth, Chandana is not there. Sanya, what is the effect of temperature?
The conductivity increases in conductors with increase in temperature.
When you increase temperature in the conductor, resistance increase. So conductivity
Decreases.
will decrease. Resistance increase, resistivity increase, so conductivity decrease. Very important you have in current electricity also same concept. Correct?
Yes, sir.
Why? Because conductor already have free electrons. So there is already maximum conductivity. When you increase temperature, nucleus will vibrate. It will create hindrance for the electron movement. So resistivity will increase. In case of insulator, you know there is already mm, what we can say most of electron are not moving. So like conductivity is least. So if you increase temperature, then there will be more free electron, and more free electron means resistance will decrease, resistivity will decrease, and conductivity increase. Ulta. And same thing happen in case of semiconductor also. Temperature if you increase, then resistivity decrease, then sorry, resistance decrease, resistivity decrease, and conductivity increase. But Anvita, if same thing happen in uh, both of these elements, if you see here in both these elements, if same thing happen, then what is the difference? Anvita, if both are same, then what is
Understand the
the
question,
difference?
sir.
My question is, if both are exactly same in both situations, if increase temperature, then resistance decrease and temperature increase, what is the difference? Are both exactly same thing? Like both are having exactly same point?
No.
No. So what happen in this situation? Here you need very high temperature you require because normally at room temperature there will be no there will be no impact on the resistance. But in case of semiconductor, same thing can happen at room temperature. Understood? Any doubt? If
No, sir.
you see about the temperature coefficient, Barinder, what is the impact on the temperature coefficient from current electricity? Sara, you tell me because you read this recently. Temperature coefficient you use R naught plus alpha T, something like that, right?
Yes, sir.
Yeah. Here it is positive because resistance is increasing. Here it is negative because resistance is decreasing on increasing temperature. Here also it is negative because it is decreasing. Okay. Any doubt, guys? As of now, that's why I always tell you, physics is not about reading one particular chapter. you always correlate with all the chapters at some or other point. Correct? So, example, if you are talking about here impact on the conductivity resistivity, you can add what is the impact on the conductance and resistance. Conductance and resistance. Who else is there? I called everyone. Jordan, what is the relation between conductance and this resistance?
So the relation, they inversely proportional to each other?
No, they are reciprocal of each other.
Oh, yes, sir.
Same way, if you see, Sarah, what is the relation of the resistance and resistivity?
So could you repeat?
Relation between resistance and resistivity.
It's directly proportional.
Is this correct?
Yes.
Resistance directly proportional to the length, inversely proportional to the area. When you remove proportionality, constantly depend upon the nature of the material, like whether you have copper, silver, gold, iron, any specific metal you have, based on that, it will change. Correct? So, conductance is again like resistance. So, conductance is high in this case, low and medium. And resistance is ulta. Here low, here high, here medium. So most of thing will be like this only. So last example. Barinder, what are the example of the conductor? Metal. Anvita, what are the example of insulator?
So would
Like many non-metal are also there. Many non-metal are also there. Correct. And Sania, example of semiconductor. Other than that, sometimes there is a compound insulator, semiconductor, like two or more element are present. Example, gallium arsenide, cadmium sulfide, and sometimes there is a organic in semiconductor like anthracene. So there are different type of semiconductor. This is like pure form. This is the compound form, and the lower one are the organic form, like anthracene, polypyrrole, and many more. Polypyrrole. Any doubt?
So just a question, sir.
Yes.
So in types of conductor for this year, do we have only N and P type, or do we have like the N and N junction and P junction?
You are very good question. And to justify what do we have here, I have sent you yesterday a PDF.
Yes, sir.
So we can check that part. Public notice. See, last year, I guess, but still, semiconductor introduction, semiconductor diode, P and end, IV characteristic of forward and reverse bias. Then you have a rectifier, very important. you have LED, you have photodiode, you have solar cell, Zener diode. Zener diode as voltage regulator, logic gate, or and not and not.
Got it, sir.
Is it exactly same like last year? Any difference at all?
No, sir.
Huh. So remember when it comes to the IV characteristic, current and voltage, it is for forward and reverse bias, and this is for LED.
Got it, sir.
Then okay, uh, sometime last year, I think we had really good notes from this chapter, isn't it?
Yes, sir.
Like I still remember we made proper tables last year.
So, but then last day we didn't write notes like on top of the notes which you had, so we did extra writing on that. That's why it was like very, very informative.
Yeah. So, but last year, in the later stage, we found that we can do this process of screen sharing. Earlier, we used to write
Yes,
in
sir.
the
That was such
whiteboard
a
of the
hectic thing.
Zoom, right?
Yes, sir.
It was so hectic to make PDF, then do stuff, and it was not proper. And we miss anywhere in between. Here, everything is saved. So this is the basic introduction based on the conductivity or resistivity. Whether they are conductor, what is the conductance, what is the resistance in each situation. You can also compare uh, all the electronic device based on the energy band. What is the level of energy band? Example, in this case, we will talk about two important bands, conduction band and valence band. Correct? Okay. So when we talk about the energy band, in case of solid, liquid, sorry, in case of conductor, insulator, and semiconductor, it is how you draw the energy diagram. Understood? How you draw energy diagram. In this case, most important part is the outer shell electron you should always consider. Outer shell electrons are considered. Example, if you take silicon, silicon is one of the popular semiconductors, then an atomic number is 14. So you will 284. So you will focus on the outer four electron. How these four electron interact with the another electrons, right? Not on the inner electron like 2 and 8. They are like noble gas configuration. Make sense? Only outermost shell will impact all the energy level. And based on this energy level, you have two type of band. One is the valence band. Sir, what is valence band?
So the valence electrons are there.
Lower energy band. Energy band that have less energy and more stability. Correct? Less energy and more stability. Why? Because this lower energy band contain the valence electron. And you know about, like in case of silicon, these four in the green are the valence electron. Correct? So it contain valence electron. One thing. In this valence band, you will say electron are present. Uh, Maybe some electron could be present or are completely absent. No, no, no. Completely absent is not possible. Completely empty is not never possible in case of valence band because in valence band there is always electron. So this band is either partially filled or fully filled. This is, it is partially filled or fully filled, but it is never empty. Why? Because every element will have some electron in outermost shell. Even if you have noble gas configuration, valence shell electron will be 8, correct? That's why you will see they are never empty. Either they are partially filled or fully filled. Valence band. Because in case of conduction band, they could be empty because there is no excited electron. Make sense? Any doubt? And last thing about this valence band electron is electron present in this are not responsible for the current. Why? Because energy is very, very low in this situation. Energy is very, very low in case of valence band. Second is the conduction band. Okay, so who will tell me? Anvita, tell me what about the conduction band comparing to the valence band. Everything compare with the valence band. Energy band. Anvita, fast. In case of conduction band, which type of electron will be present? In this case, what will be the band nature? Is it partially fully filled or empty or what? And what is the role of the electron in this situation?
Uh,
Hmm.
there are no electrons, right? I've forgotten, sir.
First thing is, in case of valence band, electron have very low energy and highly stable. But whenever they move to the high energy level, then this high energy of the electron is responsible for the current. That's why here you have conduction electron. Okay, here you have conduction electron. In case of valence band, you have partially or fully filled band. But here it could be empty or partially filled. Because if none of the electron is excited, then you can say if it could be empty. And if electrons are excited, it means it is partially filled. Okay. Any doubt? In this conduction band, electrons are responsible for the current. It is responsible for the current. And that's why, example, Sarah, if you are writing the difference between the balance band and conduction band, you can write energy band, low energy level, low, high, nature of electron, valence electron and conduction electron. Third, band, uh, band filled, fully or partially. In case of conduction, band filled, empty or partially. Valence band, electron uh, is not responsible for current. Conduction band, electron responsible for current. Okay, so same thing will work for your exam also. And you need specific information like this. See what is their level because remember, you will never do mistake in modern physics. You can't do even a single mistake. It is like haram. It is like sin. You can imagine. in your life if you are making any mistake from the modern physics, because you will never get easier chapter than this chapter. Any doubt?
No, sir.
So when you go to know, okay, there are two band, valence band and conduction band. It means there will be some energy gap between these two bands, and this energy gap between the two band is known as band gap. So if anybody asks what is the gap, sorry, the, if somebody asks what is the band gap, so it is the energy difference between the valence band and conduction band. Example, if you have electron present in the lower energy, this will be the valence band. Then, if electron get excited, they will move to the next band known as conduction band. The energy gap between these two are known as band gap. Energy gap between these two is known as band gap. This band gap is also known as forbidden energy gap. Energy gap between these two. So, how to define what is this energy gap? It is the minimum energy required to shift electrons from the valence band to the conduction band. Remember minimum. Only this word is important in this case for me. Minimum energy required to shift electrons from valence band to conduction band. Valence band to the conduction band. Okay. So that's why this energy gap you will define as conduction band energy minimum minus valence band energy minimum. Okay. Then minimum energy gap. It means you sorry. One thing. This it should be actually you should take in the middle. In the any of the thing wherever you will see it will look like this. But because we are talking about the minimum energy, so example, if any electron is present here in the conduction band, what will be the minimum energy required to reach the minimum level of conduction band? Because once electron enter into the conduction band, there will be current. If electrons are present in the valence band, there is no current. Example, if you take a wood, in case of wood, there is uh, no electron in the conduction band. That's why you cannot pass electricity through the dry wood. Okay. But if you provide extremely high temperature, maybe uh, very high temperature, practically it is like wood is always uh, insulated. So if you provide very high temperature, electron will get very high energy. This high energy is responsible for the current movement of the electron. Any doubt, guys?
No,
Uh,
sir.
Sania, what are the factors that will decide what is the amount of this energy band, like energy band gap? What are the factors that decide what is the amount of this energy band gap?
The temperature.
Temperature, nature of material,
Yes, sir.
so nature of solid, whether you have conductor, insulator, or semiconductor, correct? And how two atoms are separated, interatomic separation, correct? Interatomic separation between two. Along with that, as you mentioned, depend upon the temperature, because if you increase temperature, then this gap will definitely reduce. But temperature is not the biggest factor. Reason why? Example, if you have wood, whatever temperature you increase, wood will never pass electricity if it is in the dry state. If you make it uh, like wet, put in the water, that is a different thing. That is because of water, not because of the wood. Correct? Make sense? So that's why temperature is not the biggest factor. Example, uh, if you try to increase the temperature of the wood, it will burn, but it will still remain, what you say, it still remain insulator. Make sense? It's just key energy level will be slightly higher. Any doubt?
No, sir.
Any doubt, guys?
No, sir.
So dependency is the minimum. Minimum. Next, if you see this energy gap, then same energy gap is known as forbidden energy gap. What is Barinder? What is the meaning of forbidden energy gap? Why we call it as forbidden energy gap? Guys, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, Barinder, what is this forbidden energy gap and why it is called as forbidden energy gap?
Energy between two gaps.
And energy between the two band. So, band gap is also known as forbidden energy gap. What is the reason why we call it as forbidden energy gap? Because, okay, because there is no free electron exist in this region of the energy gap. Okay, either electron will be present in the valence band or conduction band. They will never be present in this energy gap. कुछ कहना चाहा है? मैं कुछ कहना चाहता बता दिए. हाँ, okay. Because no free electron. Good night. हाँ, हाँ. No free electron exist in this region. Why? Because electrons are either present in the valence band or conduction band. It's like कि, uh, you know atomic structure. If electron is present in the ground state, let's say it is the valence band. When same electron get excited, go to the excited level, next shell, then it is the conduction band. Makes sense that how it is work. And guys, in case of hydrogen, this is the nucleus. This is nucleus. First, we will have electron in the first shell. Let's consider this is ground state or valence band. But when same electron jump to the excited shell, then it will be the it will move in the valence band to the conduction band. Here it is valence band, here it is conduction band. So you know either this electron will exist in second shell or first shell, not in between. Make sense? Either it will lie into the conduction band or valence band, not in between. Okay. Next thing is because as of now, whatever you are reading, you always assume ki, okay, there might be some valence band, there might be some conduction band. But as of now, tell me how many of you, like Sania, tell me how many times you have visualized this basically valence band is the ground state and this is excited state, nothing else. Have you been told the same thing ki this is the literal meaning of the valence band and conduction band?
No, sir.
Jordan,
No, sir, no, sir.
Tara,
No, sir.
Anvita,
No, no, sir.
Barinder, चार्ज हो भाई लाट आ रही है कोई नहीं मैं करूंगा
No, sir.
हाँ because the I have personally seen even I was told same thing कि imagine one electron is present in the valence band when it is not passing any current and when it pass current it convert into the conduction band like we always visualize like this right as of now you always did the same stuff but when we visualize this we can't correlate कि why electron are not present in the energy gap they could be in between also but reason is this कि electron need some space to live in correct either they live in the upper floor or they live in the ground floor they can't lie in between like inside the wall make sense whether person live on the first floor ground floor or some other floor but never in between that's why electrons don't exist in this tree gap understood so what is the width of this forbidden energy gap I will write it forbidden energy gap FEG. This forbidden energy gap depend upon the nature of substance. On nature of substance. Why I'm saying nature of substance? Even among the metal, the conductivity nature can vary. Correct? The conductivity of gold and conductivity of sodium is different. So nature of element, nature of substance will decide the uh, like this energy gap. Usually, in case of conductor, it is negligible. In case of insulator, it is too much. Correct. In case of conductor, it is negligible. It is negligible. And if it comes to the insulator, then it will be wide, very wide. It will be wide. Guys, any doubt in this?
No, sir.
Anybody have doubt? Because trust me, if you understand this, you will easily understand PN junction. What happened in the N type of semiconductor, P type of semiconductor, why it is close to the valence band, why it is close to the conduction band, everything. Like N and P will be easy if you understand this. Varinder, if this forbidden energy gap is wide, what does it mean? It means valence electron are strongly attached, or you can say strongly present in ground state, and it will be close to the nucleus, means it is highly stable. Close to the nucleus, then it means highly stable. Correct. What is the impact of the temperature in this situation? Hold on. Sarah, if you increase temperature, what will be the impact?
So the energy gap, the forbidden energy gap will decrease.
Yes, it will decrease, but slightly. Like, because we already said this, that's why the more you focus on the uh, basic, then you will never face issue. See this statement. If temperature have minimum role in this case, but there will be slight difference. Definitely there is a slight difference. If energy is slightly low, it can increase. But like Sarah, your mic is on.
No, sir, no.
Whose mic is on then? There is no.
Sorry, sir.
Okay, no issue, Pratikya. So, if you increase temperature, then forbidden energy gap will reduce, but slightly. So, let me tell you one thing, though I must have told you before. Basic thing never asked in exam directly, but you can never do any tough question without knowing the basic. The more difficult question is, the more basic thing asked in the exam. Example, JEE Advanced always asks most basic thing rather than the most advanced thing. Though its name is JEE Advanced, but still it always asks the most basic thing. If you have solved, attempt any question in physics chemistry, it always asks basic thing in a way ki you will feel ki, oh, I never imagined ki we can think like that also. Try to attempt some question. Don't try to solve ki I have to solve it. Just see ki what is the nature of the question. You will enjoy the process. Understood? Because for I was teaching someone a mind chapter. Okay, and then I taught many basic thing, and after that, he, person could solve all the difficult question, and we solved many question, and it was like, oh sir, this was so easy because basic take more time. Basic take more time. Move to the next part. So there will be classification based on the energy gap. Example, if you say in case of conductor and um, what will happen, valence band and conduction band will sometime overlap each other. Okay, so they are overlapping each other. This is the valence band. Above one is the conduction band. They will overlap each other. And when they overlap each other, then you know electron can freely move from the valence band to conduction band. No energy is required in this case. So this is for the conductor. In case of insulator, this gap will be too big. Example, this is the conduction band and this is the valence band. So two shell, it just imagine ki distance between the two shell is so big that no electron can jump from the ground state to the excited state. And this gap is more than 3 electron volt because energy is measured in the electron volt in this situation. This is insulator. It means electron cannot jump. Even if you increase temperature, there is no major difference. In case of semiconductor, it lie between conductor and insulator because always this is the situation. And if it lie in between, then this gap will be very less. But big enough, he, it can restrict electron in the valence band whenever required. And this,
So,
yes, Jordan.
so I'll have to leave the meeting. So apparently the coaching centers kept a surprise test for today in another 30 minutes.
Yeah, yeah, sure, no problem.
Okay, thank you, sir.
Okay, guys, any doubt? Tell me based on this diagram.
No, sir.
So, conductor over band overlap each other, insulated too much gap more than 3 electron volt, and semiconductor gap is less than 3 electron volt. Usually it is 1 electron volt, but less than 3 electron volt is what semiconductor are considered. Uh, yeah, so when it comes to the conductor, because there is no gap between the conductor and insulator, so energy difference will be zero. Forbidden energy gap will be zero, so all the electron can easily move. That's why you will see conductivity is very high and positive. Example, if you see conductivity 10 raised to power 2 to 10 raised to power 8, no need to focus on the number. Just compare what is the unit of the conductivity per ohm per meter or Simon per meter. Correct. So what you need to focus on is conductivity is positive. And because conductivity is positive, that's why it can pass electron from one band to the another band. Correct. In case of insulator, same energy gap is more than 3 electron volt. So it will not allow movement of electron from the valence band to the conduction band. So no electron can get excited, and that's why you will see conductivity is very low. And last, semiconductor. In this case, energy gap will be less than the 3 electron volt. Some electron can move to the conduction band, some cannot. That's why you will see in this case conductivity range can be from minus to plus both. It could be very low -6 and it could be good, decent 10 raised to power 5 per ohm per meter. Right? Yes, Pratigya. Okay, sure. ठीक है. Okay. Okay. So, but any doubt, guys, as of now? Anvita, Sania, Sarah, Marinder, Chandana.
No, sir.
No, sir.
No, sir.
But don't you think, guys, here I wrote per ohm per meter. I wrote here ohm per meter, and nobody asked, sir, how you have two different unit for same thing. Don't say कि सर हमें आप पे भरोसा है अगर आप कुछ गलत नहीं पढ़ाओगे.
Sir, I just thought you wrote it by mistake.
Okay. I thought you will say, ki, sir, we trust you blindly. Don't worry. Whatever you teach, you will be right. How there are two different units for the same. It is not possible. That's why to cross check whether like where we made mistake, you can use this formula R is equal to rho L by A. If you see rho, rho will be equal to R A by L. R is ohm, A area, L square divided by L, it will be ohm meter. And you know, um, conductivity is opposite of the resistivity, so it will be per ohm and per meter. Tell me, any doubt?
No, sir.
And raised to power, what was the value? -6 to 10 raised to power 5 na, per ohm per meter. Okay. So always ask your question. Many a time I make mistake and I assume that ki you will tell me, ki, sir, how this happened. Sometime you ask it and sometime I cross check it. Ki, but I'll make sure ki I don't do mistake. If I do, I will rectify it whenever possible. Okay. Okay. And now we can talk about pure semiconductor. As of now, we were comparing conductor, insulator, and semiconductor. Now onward, everything will be correlated only and only to the semiconductor. Chandana, what is semiconductor? Based on what we did,
Sir, like based on what?
based on whatever you know. I think I started class around 5 o'clock, right? Because I sent the link at 4:30. Yeah,
Sir, like conductivity between conductor and insulator.
yeah. So can we say this semiconductor is a solid, have medium conductivity, resistivity, resistivity, forbidden energy gap less than 3 electron volt and many other stuff. Correct? Example, there are different type of semiconductor. It could be element type. Ki only one element is present in the semiconductor. Example, silicon and germanium are the two semiconductors present in the periodic table. Other than that, we have the compound semiconductor. Compound means mixture of two or more elements. Example, if you take inorganic, means specific element from semiconductor like property. See, it can never get exact semiconductor property. Semiconductor like property. Example, cadmium sulfide we already wrote. Gallium arsenide we already wrote. Or cadmium, selenium, or iridium and this. So usually you will see there are elements from the group 13 and group 15, but there could be some elements from group 12 or 16 also, like cadmium is group 12 element and sulfur and selenium is group 13. So usually see the best Semiconductor live from in group 14. Who came? Jordan came back. Gangster is back.
So I decided to skip the test with my dad's permission.
What he said.
He said, I told him the test was supposed to be at 5:30. They haven't even given any update on which app the test will be on, how where to log in, nothing. So he's like, it's okay,
How
go
many
ahead,
apps do
skip
they
the
have?
test. They have 3 apps,
Wow.
all
Okay.
unnecessary. They have
Okay.
2 other apps which I don't consider. Waste it is.
Okay.
So yeah, I'm skipping the
Guys,
test.
sometimes do you feel most of the coaching institute look like they just want to make money?
So we don't
Exactly,
think it
sir.
is the fact. It is well established fact. It is it is a truth that many of us know. Open truth.
Example, Sania, last year you were studying in SVM, a
Yes, sir.
well-established coaching institute and like a big institute where CM is coming for the program, right? CM level people are coming. But imagine you were there. Were they really bother what Sania is doing, how Sania did in the exam, what they could do to make Sania better next year? Are they bothered what
Sir,
Sania is
they
doing right now?
actually, if a child has paid the full fees, they don't care what the child is doing. Even if he or she is attending class or not, even if he or she is doing well or not, they care about nothing else. If once the fees is paid, then the job is done. Nothing else they want to care about.
Okay. Jordan, more or
And
less
this is
same
the
stuff.
case in most of the coaching institute. I'm not talking about
Same
only
thing in Chaitanya.
SSVM.
Even in Chaitanya, same thing.
Yes, sir, because here many students used to live in hostels also. So many students who paid the full fees, they are not attending classes.
Uh,
No one is just paying attention also.
okay. And example, Anvita, you are not attending Allen class from many days or month. Like, are they bothered ki what Anvita is doing? Is she doing
No,
well? Is
no,
she
no.
okay?
Like if I go tomorrow, for example, they'll ask and stuff. And but
But
like
they are never
they've
bothered
not
ki
sent a message.
she she might not well or maybe having some issues. So let
Yeah,
somebody
they're
ask.
not. No. If I go, they will ask, but like not they've not texted or
And
called.
when you go, they will ask it more like ki they are not much bothered. It's just ki they saw you after a long time. It's just ki
No,
oh,
they will
everything
ask.
is fine.
They scold also if you don't go, and then after like a lot of days you go, they'll be like, "What happened?"
Uh,
And if the reason is stupid, they'll scold you. But like
which
other,
is good thing, which is a good thing. But at the same time, they are not bothered ki from how many days you are not going. What is the
yeah,
reason?
yeah, they don't like they ask,
Okay,
but like not online. Like if we go, then only they ask.
Sir,
okay,
but in
Jordan.
SSVM, there were some faculty members who were actually concerned. Like, why are you not
Like
attending classes? And they actually care about students. Have you eaten? How is your health? Like that. They were some
who
faculty members were good.
who
Golapalli sir was like he was a
he is
gem.
very innocent person.
Yeah,
He is
he
very
is
kind.
really good person.
Jam. Yeah.
And according to my sense, um, Pratap sir was also he is more like student concerned faculty, I think.
Okay.
And mm, and yeah, I
Was there a
don't
guy from
remember.
Haryana?
Sir, yeah, you were there. Means if I will start talking about you, then it won't stop. So
अरे रे
Let's
रे
keep it
रे रे
aside.
रे 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 अरे रे 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 बस हम
नहीं
लो अपने
सर,
आप को।
हम लोग हॉस्टल में रहते थे तो हमें ये सब चीजें थोड़ा मतलब हमारे लिए बहुत मैटर करता था कि टीचर हमें पूछ रहे हैं कि हाउ आर यू डूइंग इन योर स्टडीज, और दीज यूज टू कंसर्न अस अ लॉट। तो हमें कोई
हम्म
पूछता था ना कि कैसा चल रहा है पढ़ाई, क्या कर रहे हो, कैसे पढ़ रहे हो, तो वो बहुत अच्छा लगता था, वो बहुत अफेक्ट करता था।
इन Chaitanya nobody is asking
हाँ।
or not many
चैतन्य के
people
बारे
asking.
में ना ही बोलूं तो अच्छा है।
Do you feel like whenever you leave one coaching institute and enter into other, you start liking your old institute, doesn't matter how bad it was,
या
and
सर,
you start
इट
hating the new
इज
institute,
ट्रू, इट इज सो ट्रू। मतलब
right?
वहां पे एटलीस्ट कुछ तो फैकल्टी थे जो पूछते थे, और वहां पे
हाँ,
स्मृति थी। मतलब क्या मतलब, अच्छे
like
अच्छे
there were some
बच्चे।
friends. हाँ,
हाँ, या आई मिस एसएसवीएम समटाइम्स।
हाँ,
लाइक अगर मैं
okay,
एसएसवीएम नहीं जाती तो मुझे बहुत सारे अच्छे अच्छे लोग नहीं मिलते।
got it. Jordan,
Sir, you asked so many questions. I need to know what exactly do you want to know from me.
my question was like, what was my question? Like, do you feel most of the coaching institute doesn't
Basically,
matter which one is more like money fetching rather than caring about whether you are attending on time,
sir,
though your
see,
institute is
compared to
much better
NMC,
than other.
this institute is much more better than compared to NMC and Allen thing. But still, they're also very money minded. They'll act like as if they care about you, but they honestly don't, because you can see it through their lives and all. We're like, oh, we'll hold counseling session, this and that and all. Nothing they've done. Only one student out of like the 160 they call, who's the lowest in class.
Okay, but example, if you are here in Bangalore from last 1 month or 1.5 month, like, do they really know what exactly you are doing?
No, they don't even care to ask, nothing. The students are more, like my friends are more concerned than the teachers
Yeah,
or
yeah,
whoever.
exactly. But like management asking you after
No,
every 2 3 days
management
or
don't care.
a week. Okay,
No, nothing.
okay. Chandana, you never been to coaching institute, so can't ask. Sarah, how is your situation in the school? Like, are they bother about what you are doing every day, or at least once in a week or once in a
Like
while?
I was a regular student, so if I missed classes also, they wouldn't ask.
Seriously, they don't ask even if you miss class.
Yeah, like sir, like if more than 3 days and all, they would ask, but then yeah,
Hmm. Okay.
but not on everyday basis.
Okay. Varinder, how is your situation like in your school? Varinder, are you there?
Yes, sir.
कैसे situation है तुम्हारी? हाँ. So, semiconductor are two type. One is, I will write semi C. Are two type. One is pure form and impure form. Pure form means intrinsic semiconductor that have all the internal property. Nothing from the outside is added here. Intrinsic semiconductor and extrinsic semiconductor. So now we are getting the real content for our exam, intrinsic and extrinsic. Intrinsic means when you have the pure form, no impurity added. In this case, no impurity is present in the semiconductor. In this case, there is impurity. Impurity are present. Okay, that is the main difference between the intrinsic and extrinsic semiconductor. You will see कि further there is two category. What kind of impurity you add in the extrinsic? Whether you add impurity from the group 13. Group 13 type of extensive semiconductor is known as P type. And if you add from group 15, then it is N type. P type means positive type, where you have more holes. And P type means N means negative type, where you have more electron. Correct? So here mostly group 13 impurity along with group 14. And here you have group 15 impurity. Extra one electron will be present, that's why more electron in this case. And here more holes. Though you know about this, but this introduction part is important, and now we can talk about one. We'll finish this uh, pure semiconductor because extrinsic you have a lot of content when it comes to the extrinsic.
Just a question, sir.
Yeah,
So my mom wants to know what time class end.
your mom wants to know what class time and we
Yes,
have
sir.
next
What time
class.
will it end? Sir,
I will stop it here.
are you
I,
sure? No, no, no. She wanted to know.
no. It's just like my rhythm broken. So I
I'm
don't
very
want.